In this video, we will be talking about unit conversions with derived units, which are units that are given as combinations of base units like kilometers per hour or grams per cubic centimeter. How do you know that 60 miles per hour is 26.8 meters per second, or that 25 feet per minute is 12.7 centimeters per second? Sure, you can plug it in on Google and it will give you the answer, but how does the conversion actually work? Hopefully we can demystify this together. When you make unit conversions, you are doing just that, converting by focusing on the units. The quantities are important to keep track of, but the units are what this process is all about, so we will be using them to work our way through the conversions. Let's look at an example. Let's say you're told that a person is running 10 kilometers per hour and you want to find out how fast that is in meters per second. Well, you start by writing your given number as a fraction, mirroring the format of the units. 10 kilometers per hour means that you travel at a rate of 10 kilometers in every single hour that you are running. At the end, you know that you want to have meters per second, so you know you need to change kilometers to meters and you need to change hours to seconds. Let's pause here. I think we need to make a little math note before we get started, because this really is the key to making unit conversions. Unit conversions are made possible through something pretty fancy, multiplying by 1. If I take a number like 3/4 and multiply it by 1, what am I left over with? 3/4. If I take a number like 5 and multiply it by 1, what am I left over with? 5. Well, there's many other ways I can express the quantity 1, an infinite number of ways, in fact, by using fractions. What is 3 times 5 over 5? Well, that gives me 15 over 5, which is 3. You see, I haven't changed the number because multiplying by 5 over 5 is another way of multiplying by 1. A number divided by itself is 1. So 5 over 5 is 1, 584 million divided by 584 million is 1, and even variable quantities like x over x or mgh over mgh are equal to 1. In unit conversions, we will use different measures of the same quantity divided by one another, like 1,000 meters divided by 1 kilometer, which are the same amount of distance, to multiply a quantity by 1, giving us the units that we are looking for without changing the actual real-life quantity of what's being worked with. So in our example, our conversion is trying to change how we measure the runner's speed unit-wise, not the actual speed the runner is running. So let's look back at our problem. It doesn't really matter which one you choose first, but let's tackle the units one at a time. I'll start at the top with kilometers. I'm trying to get kilometers to meters, so let's think. How many meters are there in a kilometer? Kilo means 1,000, so there are 1,000 meters in a kilometer. The key here is that I'm going to be multiplying the units together as well, so when I figure out which way to write the fraction, it's important that I write it in such a way that the unit I don't want cancels out. Now, I'm looking at 10,000 meters per hour. Let's work with hours. I know there's 60 minutes in an hour, and there's 60 seconds in a minute, so if I plug those in the right places, I've multiplied by 1 several times, so I didn't change the quantity itself, but now I have the correct number with the units I was looking for all along. So the jogger moving at 10 kilometers per hour is also running at about 2.78 meters per second. If you're being careful, you can also do all of this in one step without having to rewrite your quantities all over again. Watch this. Starting with 10 kilometers for every 1 hour, you can convert kilometers to meters, hours to minutes, and then minutes to seconds. And when you multiply through, you're left with your answer. Let's try one more. Let's say that a particularly strong spring has a constant of 840 kilonewtons per meter, and you want to know that same constant in newtons per centimeter, which would mean how much force the spring exerts for every centimeter it's stretched. Starting with your original constant, you have 840 kilonewtons for every 1 meter, and you're trying to change kilonewtons to newtons and meters to centimeters. So starting from the top, you know that there are 1,000 newtons per kilonewtons, and there are 100 centimeters per meter. Notice how we put meters on the top so that the units cancel out. This gives your answer. 840 kilonewtons per meter can also be written as 8,400 newtons per meter. As we end, it's important to note that unit conversions are only possible when you are working with the same quantity of measurement. Kilonewtons to newtons is talking about force. kilometers per hour to meters per second is talking about velocity. It would not make sense to try to convert kilometers per hour into newtons. You can't convert velocity into force. You can only work within the context of the quantities that you are given. With that said, if you're confused in class, don't cite this video as an excuse for not doing a problem. Politely ask your teacher first before throwing out accusations. With that, thanks for watching this video on unit conversions. Good luck!